Alright, so today what we're going to do is we're going to talk about interpreting graphs of functions. There's a lot of language in this, there's a lot of different things that you have to know how to deal with, so we're going to get into it, but be ready because there's a lot of things you might want to write down so that you have for reference. Okay, so first off, let's talk about intercepts. Intercepts are where different lines intersect either the y-axis or the x-axis. Okay, that's what the intercepts are. Now, the y-intercept, that's where the line crosses the y-axis. The x-intercept is where the line crosses the x-axis. So as something crosses the y-axis, it's called the y-intercept. As something crosses the x-axis, it's called the x-intercept. Okay, so these are important. They were important last year. They're just as important this year. You got to be aware and pay attention to what you're looking at. So what I'm going to do is I'm going to go through, there's a lot of real world examples in this, and a lot of them are really good. So we're going to go through them, look at them so you understand kind of what you're looking at whenever I give you your work. Okay, so real world example one, interpret intercepts. All right, so the physics. The graph shows the height y of an object as a function of time x. Identify the function as linear or nonlinear, then estimate and interpret the intercepts. Okay, first off, if it's not a straight line, it's not linear. Okay, so the first thing you should do is look at your graph if they gave you one and go, is that linear or nonlinear? Well, is it a straight line or not? If it's not a straight line, it's nonlinear. If it's a straight line, it's linear. One of the first things that you should look at. So here they give us our graph. It comes up and down, nonlinear. Okay? Very first thing. Linear and nonlinear, since the graph is a curve and not a line, the graph is nonlinear. Exactly what I just said. Okay? The y-intercept. Where does this cross the y-axis? That's where your y-intercept is. So since our line crosses here about what, 0,15 is what they say. The graph intersects the y-axis at about 0,15. Okay, that's our y-intercept. That's what we're looking at. So the y-intercept of the graph is about 15. This means that the object started at initial height of about 15 meters above the ground. So this height of a launched object, it started at about 15 meters above the ground. Now notice that when you look at your graph, you need to look at a couple things. First off, what does the x-axis represent? It represents time in seconds. What does the y-axis represent? It represents height, meters, I believe. Okay, that's what we're looking at. Okay, so time, height. So you should know what those are. Okay, so this means that the object started at initial height of about 15 meters above the ground. So when it got launched, it was at 0,15. Okay, the x-intercept. Well, we come over here. Where does this line cross? Well, here's 6. That's going to be a little bit past 7. Okay, so the graph intersects the x-axis at about 7.4, 0. So the x-intercept, where the line crosses the x-axis, is about 7.4. This means that the object struck the ground after about 7.4 seconds. So this is kind of a neat little graph. What that means is somebody threw something or launched it or whatever, tossed it in the air somehow, and it goes up. Now whether or not it goes forward or if it just goes straight up and down, doesn't matter. That's not what we're measuring. We're measuring the height it got at its peak and how long it took to come back down. Now look, they go up, the time keeps going. So however long it takes to come back down, that's what we were looking at, okay? So the graph intersects the x-axis at about 7.40. So after 7.4 seconds of it being up in the air, it hits the ground. That's what we're talking about here. So kind of pay attention to your graphs to understand what they're really talking about. It'll help you to interpret what's going on, okay? All right, so here's a different one. The graph shows the temperature y of a medical sample thawed at a controlled rate. Identify the function as linear or nonlinear, then estimate and interpret the intercepts. Okay, so here's our graph. First thing you look, is it a straight line or is it not? Yep, straight line. okay? So it's linear. That question should never be something that's hard, okay? You should just look at the graph and determine. Since it's a straight line, it's linear. Then estimate and interpret the intercepts. Well, we need to look for our x-axis, where it crosses the x-axis, and where it crosses the y-axis. And that's what we're looking at. So our y-intercept is where the line crosses the y-axis. So here's the y-axis, and our line crosses, right here. Well, here's 0, here's -10, so it crosses at -5. So 0, comma, -5 is our y-intercept. And then we look and go, well, where does it cross the x-axis? Well, it crosses at 1, 0. That's your x-axis. Now notice something about your y-intercept and your x-intercept. When you cross your y-intercept, your x is always 0. When you cross your x-intercept, the y is always 0. And if you notice those things, and I have to pause sometimes to make sure I'm saying it correctly, but that's what you're looking at. And a really good example is this one right back up over here, right? Here's your x-intercept, 7.4. Notice that the y is 0, okay? Up here, the y-intercept, 0, 15. The x is 0. So depending on which one you're looking at, the opposite one is 0. So if you're talking about the y-intercept, the x is 0. If you're talking about the x-intercept, the y is 0. That's very important to understand that. You're going to use that later, okay? All right, next we're going to talk about a little bit line of symmetry. So the graph of some functions exhibit another key feature, symmetry. A graph possesses line symmetry in the y-axis or some other vertical line if each half of the graph on either side of the line matches exactly. Well, that's symmetry, right? If this side is the same as this side, you have symmetry. Okay, so that's what you're looking at. But when we talk about line of symmetry, we're talking about that line that goes down where we say, this is the line of symmetry, this is the point where both sides are the same. That's what you're talking about when you're talking about line of symmetry, okay? All right, so here they give us a good example. An object launched, again, they're talking about an object launch. The graph shows the height of y of the objects as a function of time x. Again, time, height, okay? Describe and interpret any symmetry. Well, the right half of the graph is the mirror image of the left half. Again, this side is exactly the same as this side. And approximate line x equals 3.5. So they come across here, they go, hey, 3.5. At 3.5, we got a line of symmetry here between approximately x equals 0 and x equals 7. So here and here, here's our line of symmetry in between those. In the context of the situation, the symmetry of the graph tells you that the time it took the object to go up is equal to the time it took it to come down. So right here is the peak at which it starts to come down. And they said, hey, right there, it took the exact same amount of time for it to go up as it did to come down. So this 3.5 is your line of symmetry. That's what it's talking about, okay? So, and then it says, describe and interpret any symmetry exhibited by the graph in guided practice 1. Let's go back to guided practice 1 real quick. Let's talk a quick moment about that. All right, guided practice 1. So here's our guided practice 1. Guys, you're not going to have the exact same thing when you have a linear, okay? You're going to have that curve will give you a line of symmetry. But on a linear, you're not going to have a line of symmetry where it's exactly the same, okay? That's one of the things that we wanted to take a look. So that's what you're looking at, okay? All right. Now I'm going to give you a whole bunch of different information. Pay attention really closely to this because you're going to see this. Interpret extrema and in behavior. Interpreting graph also involves estimating and interpreting where the function is increasing, decreasing, positive or negative, and where the function has any extreme values, either high or low. All right, so what we're talking about here is this stuff right here. Positive, negative, increasing, decreasing, extrema, and in behaviors. All right, so these should be fairly self-explanatory. A function is positive where its graph lies above the x-axis. So if something is above the x-axis, that's the positive part. It's negative where it lies below the x-axis. So any of this part along this graph, notice it's not linear, okay? Anything above is positive. Anything below is negative, okay? That should be pretty self-explanatory. If it's above the x-axis, that part's positive. If it's below, that part's negative, all right? And then you come over here. A function is increasing where the graph goes up and decreasing where the graph goes down when viewed from left to right. Same thing as we did last year. If it's going up, it's increasing. If it's going down, it's decreasing. And you read graphs left to right in order to interpret that. These first two parts you've seen before, you should be okay with. It's these next two parts that you got to watch and pay attention to, okay? The points shown are the locations of relatively high or low functions values called extrema. Point A is a relative minimum. Okay, so notice, comes all the way down, comes back up, comes back down. The down peaks and valleys is kind of, I think that's what we call them, peaks and valleys. Yeah. So here's a valley, right? Right there is a relative minimum. Here's a peak. That's a relative maximum. That's what you're looking at. Don't overcomplicate it. You may have multiple ones of these inside the same graph, okay? You're just looking for the valley, the peak, and then seeing what happens, okay? That's what you're looking at, all right? And I read that, right? A is a relative minimum since no other nearby point has a lesser y coordinate. Point B is a relative maximum since no other nearby points have a greater y coordinate. Okay? Again, peaks and valleys, that's what you're looking at right there. In behavior, that's the two ends. Describe the values of a function at the positive, negative extremes in its domain. So you're talking about the ends, what you're looking at there. As you move left, the graph goes up. As x decreases, y increases. As you move left. As you move that way, right, the graph goes up. As x decreases, y increases. That's what you're looking at. What's happening at either end of this line? Well, over here, as you move right, the graph goes down. As x increases, y decreases. As x increases, y decreases. And you're going to see different versions of these, but they're really kind of all go to the same thing, right? So here's one where you have a peak here, a valley, and a peak, and then you have the two ends, right? So going up, sorry, I lost my train of thought. Going up, increasing, okay? That's the, I lost it, relative maximum, lost it, sorry. Relative maximum, relative minimum, relative maximum, right? So it's increasing, comes over, decreases a little bit right there, starts to increase again, and then decreasing again, okay? So relative maximum, relative minimum, relative maximum, okay? And that's what you're looking at. Now here, everything above is positive, everything below is negative, and then you have your two ends, okay? As you go to the left, as x decreases, so does y. As you go here, x increases, but y decreases. That's what you're looking at. You need to be able to identify all these different parts of this graph. You're going to see this. We're going to see more of it later. Okay, so be aware of this. That's what you're looking at on your graphs. Okay, and then here's their whole description of it, just so you can kind of check me and see what it looks like. But that's what it is. Okay, and you can see as you move to the left, the graph goes down. As you move to the right, the graph goes down. Okay, and that's what you're really looking at. You're going to see some of these. Make sure you know what the end behaviors are. Make sure you know the extrema, the relative minimum, the relative maximum. what it means to be positive or negative on a graph, whether it's increasing or decreasing. If you can do all these things, you're gonna be in really good shape and be able to read a graph pretty well. Do you have any questions?